So, solving linear inequalities. This is the balance method, right? Now, when we first learned to do this, we did this with boxes, right? You guys all hated it, I think, because it took too long to draw the boxes. The balance method was way easier, right? When you do something to the right-hand side, your right-hand side, you do something to the left side, right? Okay, it's the same thing here. Now, let's write an inequality for this. What's the number on the left? 7 what? What's G? Grams. Okay, what's the number on the right? 9 grams. Okay, what would we write as an inequality? 7 grams is less than 9 grams, right? Eating the bigger number or pointing at the smaller number. I don't care how you remember it. Eating the bigger, pointing at the smaller. Okay. Here's a question for you. I take 2 grams and I add it to the left. What's going to happen now? They're going to be equal. But if I don't want to change the way the scale looks, right, but it's tipped this way, if I add 2 grams to this side, what do I do to this side? Okay, so basically what you're saying is, okay, if I add 2 grams to this side, what do I do to this side? Okay, so what's this number now? 9 grams, this number here is 11 grams. Does that sign change? Is 9 still less than 11? It is. Is that correct? So if you do something to the left, you do something to the, but the sign does not change. Okay, what if we did this? 7 grams, let's write it out again. What if we took away 3 grams from the left? What would we have to do to the right? Take 3 grams away from the right, okay? So what's 7 minus 3? 4. 9 minus 3? 6. Does that sign change? Is 4 still less than 6? It is, right? So what we're saying then, guys, basic concept here. Is that the same rule that we did when we did it with an equal sign? If you added 2 to the left, did you have to add 2 to the right? Yeah, it's the same rule. Nothing changes. Okay, so let's write it out. We're still in the first box on the little notes there. We have some room here, so let me write this down here. When the same number is added or subtracted from each side of an inequality, yes, you're supposed to write this down. Yes, of course I heard that. Hey, guys, enough, please. So when the same number is added or subtracted from each side of the inequality, what about the sign? Does it change? That's the key there, right? So the inequality sign does not change, stays the same. I don't care what you say. The inequality sign does not change. So what we're saying then is it remains true, right? See, that's basically what an inequality is, right? It's a true or false statement, right? In this case, is 4 less than 6? Is that true? Is 4 less than 6? Yeah. 4 is less than 6. That doesn't change. So no matter what we do, right? In this case, we go back. It was 7 is less than 9. We added, so we subtracted 3 from both sides. The inequality is still true. It's still true. It doesn't change. Okay. So, do you still have room on that box? You should still have a little bit of room on that box.
I like no room.
Well, then don't write so large. We're still in that first box. Okay. So here's a question for you. Or here's the little one. This is an equation. H plus 3 equals 5. There it is. We've done tons of these already. The key to solving any equation is to get the variable That was horrible. Let's do that again. The key to solving any equation is to get the variable by itself. Is h by itself? No. What is attached to this h? And how is the 3 attached to this h? By adding. By adding. It says plus 3. So how do we get rid of it? If you minus 3 from this side, what do you do to the other side? Okay, what happens to these 3's? They're gone. H equals 2. That's an equation. We did tons of those. What if it's an inequality? H plus 3 is less than 5. So the main part of it looks the same, right? But instead of an equal sign, we have a one of those things. What are they called? An inequality. In this case, it's less than 5. Okay. Is h by itself? No. How do we get rid of the positive 3? Negative 3, and so what do we do on the right? Negative 3. Those are gone. H is less than 2. So you can still do the math, even though the sign is different, right? The inequality is different. You can still do the math. That doesn't change. Okay, second box, the one at the bottom of the page. What we have on that box is solve the inequality, verify the solution, graph the solution. 3 parts. This is a standard way that you're going to do one of these questions. Okay? There we go. There's the inequality. 6.2 is less than or equal to x minus 4.5. Okay. The key to solving any equation is to get the variable. Oh, guys, that's horrible. The key, come on, all together. The key to solving any equation is to get the variable by itself. Okay. Is x by itself? No. What's attached to it? What's negative 4.5. So how do we get rid of that negative 4.5? If you add it to the right, you add to the left. Okay, you do that. So we add 4.5. Okay, what happens to the 4.5s on the right? No, they don't die, they disappear. Okay, what's 6.2 plus 4.5? 10.7 is less than or equal to x. Now, how is this different from the stuff we did yesterday? Day before that. How is it different from the stuff we did the day before that? Where was the variable in that case? This one is the right side. The variable in the other days was on the left side. Oh, okay. Oh, shoot.
I don't like this.
You don't like it when the variable's on the right or the left?
I said anyway.
We're just doing algebra. Okay. Now, guys, here's a question for you. If you don't like it the way it's written, can you rearrange it?
I got it.
What do you think?
X
Okay, hang on. So you want to rearrange it so x?
greater than and
Okay, now why did you switch the sign?
because the X is all about like the other side of it, and the X is greater.
Look here. Look at the first one. Is it eating the x? So this one, is it still eating the x? Yeah, you can't change that. So basically what we've done is, could we take basically this sucker right off the page, turn it around and put it back down on the page? Yeah, basically x is now on the left. So, it's pointing to the 10.7, it's pointing to the 10.7. It's eating the x, it's eating the x. Now, why did I do it this way over on the right? There has to be a reason for that. What? Isn't it easier to graph when we do this because we know what direction we're going to point the arrow? Yeah. Okay. How do we verify the solution? Let's do that first. This was A. How do we verify the solution? Take the answer and put it in where? The original inequality. Plug it back into the original inequality. See if the left side equals the right side. That's how you tell if it's true. Okay. So what's the original equation? 6.2 less than or equal to x minus 4.5. Okay. Now, what are we replacing x with? What are we replacing x with? 10.7 minus 4.5. Okay, what's 10.7 minus 4.5? 6.2 less than or equal to 6.2. Is that true? Does the left side equal the right side?
Yes.
So is it the right answer? You better believe it. Okay?
I do.
So we solved it, we plugged it in and verified it. Now what do we have to do?
Graph it.
Graph it. So what do we need?
Put on a graph.
No, I know it needs to put on the graph. We need a number line, don't we?
Yeah.
Okay, now, this is a little tricky, this one. Why is it tricky?
It's tricky.
Decimal, isn't it? Ah, shoot. No, you could guess if you wanted to, so you'd go between 10 and 11 and try to figure out where it is. Does the number line have to be with whole numbers? Does it have to be 1, 2, 3, 4, 5? Does it have to be? No, it doesn't. Can you do a number line with decimals? Could you do that? Oh, that's a possibility. Let's take a look. Okay, let's draw a number line. Number line. There we go. What number are we going to start at? 10.4. You want to start at 10.4? Sure, why not? 10.4. What would that one be? What?
11.
No.
5.4.
Try 10.5. Next one would be 10.6. Next one would be 10.7. Next one would be 10.8. Next one 10.9 and no, not 10.
11.
11. There. So 11.0. If we're going to one decimal place, you should put the point 0.
No.
Yes. Okay.
No.
I missed the ball from all you data meetings.
Okay. We've got to put a dot on this number line. Is it a open circle or a closed circle?
Oh,
What is it? Guys, look at the sign. Because of the equals underneath there, does it include that point? Yes, it does. So it has to be a closed circle. At what point? 10.7. There it is. Now, when we look at this, we have to draw an arrow because it's an inequality. Well, this one really doesn't help us because the variable's on the right. Right? In this case, it would be telling us to draw the line to the left, which doesn't work. So we look over at that's right there. The x is greater than or equal to 10.7. The variable's on the left, the number's on the right. And that's telling us which direction?
right.
Go to the right. So we're going to draw an arrow over to the right, somewhere in there. Just like that. And you guys, you can check to see if one of your answers are correct. Let's pick this one, 10.9. 10.9. Is 10.9? Oops. Is 10.9 greater than 10.7? Yeah, it is. So did we do it the right direction? Right. Flip the page.
My eyes are upside.
Okay. On this page, you have two blank boxes. Do you see them?
No. I know.
On this page, you have two blank boxes.
I just
I understand.
okay.
I'm going to give you, let's start with 3 in the first block. So on the first square, I'm going to give you 3 to do. Okay, here they come. What I want you to do is I want you to solve them and graph them. Solve them and graph them. So you're going to solve each one, then you're going to graph each one. So you can do 3 on this first page. So A is x plus 5 is greater than 2. B is negative 9 greater than or equal to y minus 3. And C, 4 plus A is less than or equal to 8. Okay, there's 3 for the first box. You need to write this down. Write this down. No, not with that. The pencil, please. You can't see anything with that thick marker. No, you can't. Anyways, write those 3 down. Now, guys, solve each one and draw, put them on a number line. Okay, do that. Should take you all of about a minute to do. You guys know the rule for this. For each one, make sure the variable's by itself. So do that. Try those ones quickly, and I'll just do attendance while you guys are doing that. Yeah, it doesn't stop recording, right? No, it records something. Sorry, what?
Like, I looked at the notes and almost couldn't find which kind of videos.
It's right underneath them. Did you find where your notes were?
The ones that I was doing,
Now that we're doing them, I didn't do them like for the first little while. I'm just trying to, and I'm just recording the ones that I feel are kind of important that you should know. Hang on one second, I'll be right there. Where is... No, Colette? No. Okay, solve these and do the number lines, please. Yep. Who had a question? Didn't somebody have a question back here?
I'll make your use like when you do your play.
Yeah, it records. It's on YouTube.
So when you talk, when you like yell at that.
Yeah, if I yelled at him, then it would appear on there too. I could do some if you want. I could say something funny. I could probably hear that, but could you do this, please? Okay, look. So the first one is x plus 5 is greater than 2. So you got to get x by itself. So how do you get rid of that positive 5? So do that. So subtract 5 from both sides. Because we want x by itself. If you bring the 2 over here, x is not by itself. It's down. So subtract 5 from both sides. Turn around and sit up there so you can actually do it. No, those don't cancel out. Well, just subtracting 7 minus 5 is 3. What is the number? I can't even read your writing. Oh, is that a 2? Oh my goodness. Okay, so those cancel. So x is greater than what? What did you say? No, minus 3 you said. Okay. Okay, so now do your number line. Could you turn around, sit up here, please. I don't care. Put some numbers on there and graph that at negative 3. So put on 1, 0, negative 1, negative 2, negative 3, 4. 1, 0, and all the negatives up to negative 4. Do that quickly. Come, faster. Hold your paper. Put your other hand up here and hold your paper because you're writing all over the place. There you go. Good. Where does now? Does it open circle or closed circle? This or this is an open circle. This or this is a closed circle. So which one is it? So write an open circle. Do it. Come on. At what point? Go sit down, please. Just go sit down. Go sit down, please. And did you do that? Good, you did that direction. Okay, good. Do the next one. Okay, let's go, guys. Now, guys, here we go. The key to solving an equation is to get the variable.
Myself.
Okay, is x by itself?
No.
Guys, what's attached to this x?
Plus 5.
Plus 5. So how do we get rid of it?
Minus 5.
Minus 5. Okay, let somebody else answer, please. Okay, those are minus 5, so those are gone. X is greater than? Negative 3. We draw a number line. Yes. What do you mean? Like how? Why to get rid of the 2 or the 5? Okay, now look. You want the variable, that little guy, by itself. Is there any variable over on the right-hand side? No. So the only variable is on the left. So whatever's on the left there, we're going to get rid of it. Does that make sense? Okay.
And then, don't you know, like, what way the arrow? Like, what?
Oh, hang on. Let me get the number line up on the board first. Okay, look. What do we need here? -4, -3, -2, -1, 0, 1. Okay. Now, at -3, do we put an open circle or a closed circle? Because it's greater than, so it's an open circle. Okay, now, if the variable's on the left and the number's on the right, you just look at this thing and pretend it's an arrow. Like the head of an arrow, right? So if this is the head of an arrow, which direction is it pointing? To the right. So guess which way your arrow goes? To the right. Now, would that work if it was -3 if those were reversed? If the -3 was on the left and the x was on the right? No, it wouldn't. Your variable has to be on the left. If you're forgetting that rule, write yourself a little note. The variable has to be on the left, the number has to be on the right, and then that inequality points in the direction that you're going. Okay? Let's try the next one. So here is y by itself. No. The y is on the right-hand side, and we look at what's on the right-hand side. What's attached to this y? A -3, so how do we get rid of it? Now, we +3 on the right, and we +3 on the left. Okay? So what's -9 plus 3? -6 is greater than or equal to y. Now, this one's different because the variable's on the right. If you don't like that, could you basically take it off the page, flip it around, and put it back down? So if it's pointing to the y, when you reverse this, guess what you have to do?
Point to the other way.
No, it has to point at the y. Okay, yeah, you spin the sign around. Okay, I see what you mean. So y is less than or equal to -6. Now, does that tell us which direction the arrow is going to go when we draw it on the number line? It's going to go to the left. Okay, let's draw our number line. Number line. So we need -8, -7, -6, -5, -4. We're going to put a circle at -6. Is it going to be an open circle or a closed circle? Closed because it's less than or equal to in this case. And which direction does the arrow go?
To the left.
To the left. That's good. I like that. To the left. Is it starting to make sense?
Yeah.
Different than regular equalities, right? Because you didn't have to graph it when you did inequality, did you? No. This case you have to graph it. That's one of your answers. All right, let's do this third one here. Is A by itself? Yeah, what's your question?
So, like in phase, we didn't put the line around, so our one,
It's wrong.
how is it?
Okay, well, let's say your arrow goes the opposite way.
I thought it changed.
Just watch. Let's say it goes the opposite way. So your arrow went to the right. Is that correct? So let's try -4. Right, because you're telling me -4 because it's pointing to the right could be one of your answers, right? It's pointing, okay. So let's try it. Is -6 greater than -4? No. -6 is a smaller number. Even though the number looks bigger, is it farther away from 0 on the left? So actually -6 is smaller. So the way you did that, the -4, you're telling me that that's true and it's not. Does it work for my way? -4 is less than, or did I screw it up? No, I'm right, okay. -4 is less than -6, yeah. Sorry, what?
The numbers are switched, you know.
What do you mean, sorry?
Like it's 8, and you have
Oh, if you had on the number line backwards? Oh, no, don't do that. No. Don't spin your number lines around. Did you spin your numbers around? Is that what you did? Oh. No, you need to change it so it's the variable and then the number. Yeah. Because like you picked -4. Is -4 less than -6? No, it's greater than -6. Is -8 one of our answers? Is -8 less than -6? Yeah. So if you're going to do that, right? Hey, if you're going to use the rule about this direction pointing to the arrow, make sure it's the variable first, then the number. Write yourself a note if you're going to forget that. Variable first, then number, and that tells you the direction of the arrow. Okay, look here. Is A by itself? No, what's attached to this A? What kind of 4? Positive 4, so how do we get rid of it? -4, so what do we do on the right? -4. Okay, 4 minus 4 cancels out. A is less than or equal to 4. Now, does this one have to be switched around at all? Hey,
No.
does it have to be switched around at all? No, the variable's on the left already. Okay, draw a number line. One, 2, 3, 4, 5. Open or close circle at 4. Why closed? Less than or has a thingy underneath it. Yeah, thank you. The less than or equal to. Which direction? Left or right? Left, because the variable's on the left already. That's pointing that way. We got it. There we go. Okay, bottom part of the box. 3 more I'm going to give you right away. These should be faster. Here we go. Here's D is 2 greater than x plus 7. E, k plus 8 less than negative 13. F, Q minus 2.5 less than 3.9. Okay, there's 3 more. Okay, try those. Solve them, graph them on the number line. Solve them, graph them on the number line. Write these down. You haven't, oh my goodness, you haven't even written these down. Right there. Write those down now. Have your pencil and write them down, please. Oh my goodness. Write down. Let's go. Write those 3 questions down and solve them, please. On the bottom part. Are you getting better at making your number line? Are you getting better at figuring out what numbers go on your number line? They don't always have to be zeros, right? Take a bit of practice to get these. Where did he go? Could you do these, please? Turn right around. Face the front. Grab your paper. Hold the paper. When you write all over the place because you do not hang on to your paper. You can see the difference between good writing and bad writing is how people actually write. No, it doesn't have to be. Hold your paper. No. When you do this, there you go.
It's not addition.
D, right there. 2. Right here. Down here. So do it, please. Trying to give you some skills in how to write better. If you actually follow them, you would. You'll find it's easier if your work is neater. I hate to break it to you.
I know, but...
Sorry? Where? 3.9, yeah. That's 3.9, that one. I'll fix it there so you can see it. Just do the work, please. Okay. Okay, you need to move faster in this class. You also need to sit up. Let's sit up. Because with you sitting like that, you're not doing the work. You're already falling behind. Just please sit up. Turn all the way around, too, please. Just turn. Just get in your chair and actually sit. Slide over then. Slide over to the left if you can't see it. Slide over to the left. Oh my goodness. These aren't difficult, guys, are they? You just have to do them, and that's the key to this. Hang on. Check them. You can see if they're right. How do you check them? Take your answer and plug it in. See if left side equals right side. It's the easiest way to check. Give you another half minute. Then we're going to try the word problems on the last page. Fifteen seconds. What? Variable, then number. I told you to write it down so you won't forget, so you don't have to ask all the time. Variable, then number, and then it's the direction that it is going. Okay. These are really quite simple. These ones are easy because you're only moving one thing, right? Have you noticed that? Are we going to start getting to stuff where you're going to have to move two things, maybe three, maybe four? Can I do this with fractions like we did on the last one? Yeah, you can do it. Can you do it with decimals? Yeah, you can do it with all that stuff. The rules are still the same. Okay. Is x by itself? No, what's attached to that x? Plus 7. How do you get rid of that plus 7? Negative 7, both sides, right? Okay, these guys are gone. What's 2 minus 7? Negative 5, greater than x. Well, that's difficult to do because the x is on the right. Could we take the whole thing and flip it around? Is the little arrow here pointing at the x? Yes, so when you rewrite it, does it still have to point at the x? Yes, it does. Okay. Now, so we write that as a number line now. What's it going to look like? Yeah, well, of course it's a straight line. Negative 7, negative 6, negative 5, negative 4, negative 3, negative 2. Oops, negative 2. Is the circle an open one or a closed one? Oh, it's open because it doesn't include that. So it's an open circle and it points to the left or to the right? To the left. There you go. Easy so far? Am I confusing you all? Well, because he wasn't paying attention before. He was cleaning out his binder. All right. What about this one? Is k by itself? What's attached to the k? Positive 8? Who's that? You forgot the number. That's an 8. How do we get rid of the positive 8? Minus 8, minus 8. What happens to these 8s over here? They're gone. K is less. K is less than what? Negative 21. Now, do we have to reverse this? Guys, do we have to reverse this? No. Draw the number line. Negative 23, negative 22, negative 21, negative 20, negative 19. Okay? Open or close circle?
Open.
Open. Which direction? Left. You writing this down? Of course not. You couldn't even be bothered to write this down. Thank you. This is why you're missing stuff, because you're not even writing it down. Okay, it's q by itself. No, what's attached to it? So how do we get rid of the negative 2.5? You add 2.5. To one side or both sides? What happens to these 2.5s over on the left? They're gone. So you're left with q is less than 6.4. Okay, now, here's a decimal again. How are we going to do this number line? Yeah, let's do it as decimals. It probably works as a decimal one. Might look easier, I think. Is the variable on the left? Numbers on the right, so we know our direction of our arrow. So what do you want to start at? 6.2? That works. 6.3, 6.4, 6.5, 6.6. But I usually throw a couple on either side, just so we can see what it is. At 6.4, open or close circle? Open. What direction is the arrow? Left. I think this is getting quite easy, isn't it?
Yeah, I thought we didn't have it.
No. Now the only thing is, what's going to happen, and this is going to be the end project for this unit, hey, the end project for this unit, it's going to be called the Pet Club. What it is you're going to have to raise money for uniforms. It is going to be a word problem. So guess what I'm going to give you next? Flip the page.
That's all right.
Flip the page.
Ah, it's all there. That's so cool.
Now, have you guys ever gone on holidays and put your dog or cat at a boarding kennel? You ever done that? You do not let them starve. My goodness, you mean. Alright. Now, there are two kennels that we can take our dogs to. Kennel A, how much is it? $90. You walk in the door with your dog, how much do they charge you? $90, and then $5 per day. So if the dog stays there one day at boarding house A, one day, how much? $95. If they stay there for 2 days, $100. 3 days, $105. Okay, we can figure that out, right? We just take the number of days times it by $5 and then add 90. Okay. Or you can take them to boarding house B. Boarding house B, when you walk in the door with your dog, how much do they charge you? $100. And then how much per day? So if the dog stays there one day, 104. If the dog stays there 2 days, 208. You only get charged the 101.
108.
Okay. So what we're going to do is we're going to write an inequality. So the first thing we need to do, and guys, this is interesting. It's amazing how students pick this stuff. You need to choose a variable for this inequality. What? D for what? No, well, no, because you only have one dog. What's the thing that changes? No, not the money. That's the total.
A and B.
No. A and B are the boarding houses.
5 and 4.
The days. No, the days. You have one dog. If you put it there for 5 days, 10 days, 20 days, are you going to get different amounts? Okay, so we're going to define our variable as D equals number of days.
I said D for days. You didn't say anything.
No, he said D for dog. He said over there.
I said
Oh, sorry, I heard days. I didn't hear it. It wasn't clear.
I said D for 10. Yeah. So I said D for days. I said like 5.
Okay, so here is boarding house A. There it is. There's boarding house A. Right there. What I want is I want an equation for boarding house A that uses that variable right there. Okay, you walk into boarding house A with your dog. How much is it right off the hop? Boarding house A, $90. And then what are you going to add to that? $5 per, how do you write that? 5D. Right, because we want to use the same variable, right? We want to use D for days. So for instance, 0 days, $90. 1 day, $95. 2 days, $100. 3 days, $105. Right? We can do this. We can just keep doing that, doing that. Okay? Let's do boarding house B. What's boarding house B? Plus 4D. Now, why did you do that? 100 is the opening cost. What we refer to that is, we normally refer to that as a fixed cost. It's $100 no matter how many days, right? And this one, does this one change?
Yeah.
So D is a variable, so what kind of cost do you think we call this one? Guys, let me try that again. D is a variable. What kind of cost do you think you call this? A variable cost. A fixed cost and a variable cost. Variable cost changes depending on the days. Okay. Now, which one are you going to put your dog in?
B.
Excuse me? Yeah, it depends on how many days you're away. That's dead on the money. Depends on how many days you're away. Is there a point where the certain number of days where it's exactly the same price as putting in an A as it is in B?
Yeah.
Yeah, it is. It probably is. We'll find that out in a sec. Okay. So what we do this is let's solve the problem. Okay. So what we want to do is we want to find what's called a break-even point. At what point is it exactly the same price for A and B? So here we go. Here's A. 90 plus 5D, 100 plus 4D. So we want to find when they're exactly equal to each other. So what do I put between these two things? No. I want to find out when they're exactly equal to each other. So I put an equal sign. Well, can we do this? Is this just linear? Is this just algebra? The key to solving an equation is to get the variable by itself. Are the variables by itself? What do you want to do? Now hang on, what are we going to move around? Do you want to move the 5D over to that side or the 4D over to this side? Doesn't matter. Well, let's move it all over to this side. Let's move the whole 4D. How do we get rid of this positive 4D? Negative 4D and negative 4D. Okay. What happens to these D's over here? They're gone. Okay, what are you left with? 90 plus D equals 100. Well, we're getting there. We're getting closer. How do we get rid of this positive 90? You subtract 90 from this side and you subtract 90 from this side. What happens to these ones? So D equals what? What does that mean? No, not D is not dollars. D is days. So at exactly 10 days, which kennel are you going to pick? It doesn't matter. Why? It's the same price. Okay, now this is not true. Well, I guess it is. It's true. Now, think about this for a minute. What was the first one I wrote down? 90 plus 5D. And what was the other one? 100 plus 4D. Now, in reality, I don't want to make that an equal sign. I want to make this an inequality. Which one is it? I want to make this an equality. Which one's cheaper? Are you pointing a direction or are you putting your hand up? That one's cheaper? If it's 10 days, it is exactly the same. Okay? Okay. What about this one? What would this be for? Let's try a number less than 10. Let's try 5. Which one? 5 times 5 is 25. So 25 and 90 is... So if you're telling me D is 5, the cost is going to be how much? 115. Okay. What if the D is 5 here? What's the cost on this one? 120. Okay, so what's cheaper? This one. A in this case. Okay, what if D is, let's try 15. 5 times 15. 75 plus 90. 165. Okay, what did we say? 15. 40 times 15 is 60. Plus 100 is, so what's the cost here? Oh, sorry, here, let me write this. So the D was 5, the cost was 120. Here D is 15, the cost is, what did we say? Okay, which one's cheaper now? That one. So what can you conclude? Okay, so D, 10. D, 10. I want some inequalities here. 10 is the break-even point, right? So what do I write here? I want to know. I want an inequality. I want a less than or greater than or a less than or greater than. No, not an equal. I want to know which one to pick, A or to pick B. For which one, though? For this one. Okay, so you're telling me on the first one, if it's less than 10 days, which one are you going to pick? Is it going to be cheaper? Yeah. If D is greater than 10 days, which one are you going to pick? B. Right? What if it's exactly 10 days? Doesn't matter. Right? This is inequalities. This, guys, hey, this is stuff you're going to use in real life. Quit looking at the clock. Once you finally drive, your parents might have figured this out. If they go on a trip to the States and you rent a car, do they offer different deals for cars? Yes, they do. So much to get the car and then so much per day. Depending on how long you're vacationing for, you might go with a different car company because it might be cheaper. This is something you will see in everyday life. Now, here's your homework. Here's your homework. And I will be checking this. You see the bottom question? Do that. It's an inequality. The bottom question is an inequality. That is your only homework. We're going to check it tomorrow when you come to class. You get 0.
Okay.
Just do the question, please. Not that hard.